Okay, so now we're going to use synthetic division and the remainder theorem to determine if a factor or value will result in a zero. So let's dive in. So first off, we're just going to review basic substitution, which we've been doing for a while, where you plug in a number for x and evaluate and see what the value is. So we're going to now plug in -2 everywhere there is an x. Okay? So what that gives us is 2 times -2 to the third power minus 5 times -2 squared plus 6 times -2 minus 10. So that gives me 2 times -8, -2 cubed, minus 5 times +4, -2 squared. I'm just going to simplify this to minus 12 minus 10 right now. That leaves me with -16, minus 20, minus 12, minus 10, which leads me to -58. So f of -2 is -58. If I plug -2 into that function, you end up with -58. G of x, we're going to plug 2 in everywhere we have an x. So negative, be careful here with substitution. Remember, this means take 2 to the 4th first and then take the opposite of it. It's the opposite of x to the 4th. Plus 6 times 2 squared minus 5 times 2 plus 8. So 2 to the 4th is 16, so that's -16. 2 squared is 4 times 6 is 24 minus 10 plus 8. That simplifies to 6. Now we're going to use synthetic division to basically do the same thing. If you remember in the previous day's notes talking about synthetic division, sometimes we're going to be dividing by, say, x plus 2. Okay? And in that case, we would set x plus 2 equal to 0 and solve. And we would get x equals -2. And if you remember, the note said sometimes the number will be just given to you. Like in this case, evaluate -2, f of -2. Well, that would be the same as x plus 2 if it was the divisor of our polynomial. But right now we're just evaluating. So we're going to do synthetic division, put our -2 in the box. And remember, check. We have 3, 2, 1, and none. So we're okay. We don't have to put any zeros in for placeholders. So there's our cubic value, our square value, our linear value, and our constant. Draw our line, bring our 2 down, multiply by -2, which gives us -4. Add those together, you get -9. Multiply by -2 and you get +18, which is 24. 18 plus 6. Multiply by -2 and you get -48, which you add together and get -58. Does that sound familiar? There it is. Now, basically, this is showing you that synthetic division can be a substitute or an alternative to doing substitution. So, it's up to you what your brain does better. Is it a little bit faster doing synthetic division? Yeah, because it is a shortcut. If you get comfortable with synthetic division, this is a quicker way than direct substitution. But it's up to you what you're most comfortable with. So, we're going to do 2 here. Now notice, we have our 4, 2, 1, and none, but we're missing a cubic. So what we're going to do is put -1 for our quartic. We're going to put a 0 in for our cubic. 6 for our square, negative 5, and 8. Draw our line, drop down to negative 1, multiply by 2. 0 plus negative 2 is negative 2. Multiply by 2 and get negative 4. That gives us 2. Multiply by 2 and we get 4. That gives us negative 1. Multiply by 2. Add them together. That gives us 6. Once again, look familiar? They're the same problems. G of x, x to the 4, 6x squared minus 5x plus 8. Same problem. So again, you can see that as an alternative to direct substitution, it's a little bit faster. Now, taking this one step further, we're going to determine if a value, like we just plugged in, is a 0. And remember, these are all equivalent terms. When we talked about a 0 on the last test, it's the same as the x-intercept, or the roots, or the solution to the quadratic. So in this case, these terms all mean the same thing, and we will use them interchangeably. So to determine if it is one of these things, the remainder must be 0. You cannot have a remainder, as we had on previous sheets. So here we go. We're going to do a synthetic division with 2. So we put our 2, and we have our x to the 4th term, our x to the 3rd coefficient, our x coefficient. Whoa, almost made a mistake. We have no x squared coefficient. We have our x coefficient, and we have our negative 2 as our constant. Hopefully that's my one mistake for the notes, and I did catch it. So we bring the 1 down, multiply by 2. Add those together, you get 0. Multiply by 2, you get 0. Add them together, you get 0. Multiply by 2, you get 0. And finally, when you add them together, you get 1. Multiply by 2, add those together, and you get 0. This is what we're looking for. We have no remainder. There's nothing left over. It zeroes out. So, in other words, yes, 2 is a solution. Determine the following is a solution. 2 is a solution to that quadratic. I'm sorry, that polynomial. Dang, there's my next mistake for the day. Okay, so we put 1/2 in our box. There's our squared term. There's our x to the 1 term. And there's our constant. Pretty quick. Drop our 4 down. And we get 1/2 of 4 is 2. Add them together. 1/2 of 1. Sorry, 1/2 of 2 is 1. Add them together. We get 0. Now remember, at this point, we are just trying to evaluate and see if we have a leftover, a remainder. But if we were actually going back and getting the full answer like we did in the previous lesson, we would have to multiply all these by 1/2, divide by 2, really. So when we divide by 2, we would get 2, 1, 0. Okay? Let me step back a little bit to examples 3 and 4. We're stopping right here because all we're trying to do is evaluate. If we were going the full distance, then remember, since we started with cubic, we would say 2x squared minus 9x plus 24 plus negative 58 over x plus 2. Well, we're not doing that because we're just evaluating at this point. But I want you to see the connection between what we did in the previous lesson and what we're doing here, how they still match up. And that's why down here, our answer would not be 4x plus 2, it'd be 2x plus 1. So that's why we still go one step further and divide everything by 2. Okay, negative 2 in the box. We have our cubic term, we have our squared term, we do not have our x to the first, and there's our constant. bring our 3 down. 3 times negative 2 is negative 6. Add them together to get negative 8. Multiply by negative 2 to get 16. Add them together and get 16. Multiply by negative 2 and you get negative 32. Add those together, you get negative 27. Since we have a 0 there, the answer is no. It is not a solution. So going back, we have yes, because of our 0. We have yes, because of our 0. And we have no, because we have a remainder. And once again, up here in big bold letters, to see if it is a solution, the remainder must be 0. Okay, now we're going to do the same thing with 3x minus 2. Remember, first step is to set equal to 0. Add 2 to both sides. 3x equals 2. Divide by 3. X equals 2/3. So now we have our number to put in our box. 2/3. Now, we have 9 for our cubic term, negative 3 for our squared term, negative 2 for our x to the first, and we have a 0 for our constant. We must put that, because if we don't have or if it doesn't form a solution, if it's not a solution, then we will have a remainder. We need that 0 for the remainder spot. Had a little bit of trouble talking there. Sorry. So there's our 9. Now we're going to multiply 9 over 1 times 2/3. You can think of it two ways. You can do 9 times 2 is 18 over 3, which is 6. Or you can just cancel and say 3 times 2 is 6. Either way, it is 6. Add those together and we get 3. 2/3 of 3 is 2. Once again, if you do it in your head, the 3's cancel, leaving you the 2, or 2 times 3 is 6. Divide by 3 is 2. Add those together and you get 0. Obviously, 2/3 of 0 is 0. And there you have it. The answer is yes, because there is no remainder. X plus 1 equals 0. X equals negative 1. There's our number that goes in the box. 5 is our 4th power coefficient. We do not have a cubic. Negative 3 is our squared coefficient. 6 is our x to the first coefficient. Negative 10 is our constant. Draw our line, bring our 5 down. Times negative 1 is negative 5. Add those together. Times by negative 1 is positive 5. Add those together. Times by negative 1 gives us negative 2. Add them together. Times by negative 1, negative 14. The answer is no. In other words, x plus 1 in old school terms does not go into that polynomial evenly. It is not a factor. It is not. It has a leftover. So, there you have it.